How are we going to determine the intervals in which graphs increase, decrease, or remain constant? What I like to do is plot the point in which the direction of the graph changes, and I write an imaginary line as to where the point was plotted. And then I can start answering from there, reading from left to right. So here, we'll start with negative infinity, because the graph appears to start from all the way up to who knows where, down to this point at negative 2. The second half, the right half of the graph, starts at negative 2, and then it continues on forever. That's how you graph your intervals, and how you determine them as well. Now, we're not over yet, because we need to label these as to where they've went. So the left side of the graph was decreasing, and the right side of the graph was increasing, like my money. Let's slip into problem number 2. Again, I'll plot the point of the graph in which the direction changes, and then I'll start to label with my line down the middle. Now let's answer it from left to right. You can see that the graph has been going up, so we can write infinity up to negative 1. 1 up to 1. Now that we've plotted the left side of the graph, let's hit the right side. Start off at 1, because that's where we left off, and then we'll go on to infinity. Why, you may ask? It's a constant. It's going to constantly go forever to infinity. It doesn't have to go increasing. It doesn't have to freaking decrease. It can just go in constant. Bro, I'm actually so tired of this, bro. Like, I hate this. Chat clip for me. This is so boring. Why did I do this, bro? I should have wrote a rap song. We lucked out on number 3. We only have to plot the point in which it starts at. There's no line to draw down because the graph only goes one way. Forever up. So, we can write our answer as negative 2 onto infinity. Why, you may ask? Because the graph's only going in one direction. So, we can write it over there and label it as increasing. I'm so good, bro. Oh. How do teachers do this, bro? How do teachers teach? I'm getting tired of this, dog. I hope I don't get copyrighted. You guys think it's gonna happen? I hope not. Why is there 4 viewers now? It's your sign to get on skate. I ain't getting on no skate. Okay, I'm gonna restart. We're gonna do number 4 right now. Number 4, baby. Let's slip right into it. So we notice that there's a lot of changes in directions in this graph. One over here, one over here. So I'm gonna highlight these points. One line right here, and one line right here. And now since there's 3 different changes in direction, I'll have 3 different answers. So BananaJoe is gonna write infinity because we notice it's going up, only up into 0, because that's where it stops. Again, we leave off where we left off, and we start at 0, and we see it decrease to about 2. Our last stop, our last change of direction, starts at 2 and goes on to infinity. So now we can label these. We've seen that it started from the left, it increased, and then it decreased, and then it increased again. Judging from this, that, and this as well. The whole shebang. It's pretty cool. Our final problem of the day. BananaJoe is very happy to be here. Anyways, we're going to plot the point in which the direction of the graph changes, which is right here. I'm also going to draw a line down the middle because Banana Joe needs help. So now I'm going to start answering my question. Starting from left to right, I'm going to put infinity up into 0. Because we put infinity because it started from who knows where and just kept continuing to go up. Up into 0 at least. Now we graph the right side of our problem. Starting at 0, going down to negative infinity. And we can label it as well. Going up and then going down. Because you can tell the graph goes from left to right, up, and then down. This is Banana Joe. Wait. Thank you guys for the awesome math tutorial. I hope this helps a random teenager who is failing in Algebra 3 right now. Thank you, Banana Republic, for the support. I love you guys. Peel you next time.